Hello friends, today we learn the hypothesis testing test, that is hypothesis test, that is a chi-square test. It has two types, chi-square test for goodness of fit and the chi-square test for independence. Today we learn this test, chi-square test for goodness of fit. Here we check whether there is a difference between, whether there is a significant difference between observed frequency and the expected frequencies. So this is simple example. A dice is thrown 60 times. So we know that dice have a 6 faces. It is given in the problem statement. So 6 faces are there, and how many times they are thrown. This O is nothing but the observed frequency. So for formula for expected frequency is E equal to N divided by K. N is nothing but the total observations. So total observations 60 is already given to us. And the number of categories. So how many categories are there? 1, 2, 3, 4, 5, 6. So there are 6 categories. So answer is 10. So value of E is 10. And we will check whether this observed frequency and these expected frequencies are having significantly different or same. We will check this using this test. Now we calculate the test formula, that is a test statistics. So we use symbol T for T test for calculating the test statistic. In case of chi-square test, we use the symbol x square. This symbol is for test statistics. Its formula is summation of I equal to 1 to n. N is nothing but the total number of observations. So I can write like capital here also. And in bracket, O is the observed frequency, E is the expected frequencies. O minus E square divided by E, that is the expected frequency. So I will change the formula as I have value of n is, it is a n, small n, it is nothing but the K. I can write K here also, number of observations. So it is from I is equal to 1 to 6, O minus E square divided by E equal to. So observed frequency is suppose first 8 minus expected frequency is 10, it's bracket square. Here I will make a summation, so I would add one by one. The next value is 10 minus expected frequency is 10 bracket square, plus 9 is the observed frequency, 9 minus 10 bracket square, plus 11 minus 10 bracket square, plus 12 minus 10 bracket square, plus 10 minus 10 bracket square divided by expected frequency, that is a 10. So we know that 8 minus 10 is minus 2, minus 2 square is 4, plus 10 minus 10, that is a 0, 0 square is 0, 9 minus 10 is 1, 1 square minus 1 square is 1, plus 11 minus 10 is 1, 1 square is 1, plus 12 minus 10 is 2, 2 square is 4, plus 10 minus 10 is 0, 0 square is 0 divided by 10. So it is total 4 plus 1, that is 5, 5 plus 1 6, 6 plus 4 10. So it is a 10 divided by 10. So answer is 1. So the value of expected frequency is 1 here. Sorry, it is a value of x square. That is a test statistics. So this is calculated value. This is a calculated value using this test. I will compare this value with critical value. So alpha is given in the example, it is 0.05, that is, it is 5%. If it is not given in the example also, I will consider this as a 5%. The value is given either 1% or 5%. If it is not given, you can consider any value, but normally we consider 5%. 5% means it is a 0.05, alpha is there. And degree of freedom is calculated using this formula. This formula is different for every test. For goodness of fit test, this formula is K minus 1, where K is the total number of observations. So value of K is 6 here. So 6 minus 1, that is a 5. So value of DF is 5. Now I want to find out the critical value. Critical value is a T 0.05 is the alpha, comma 5 is the DF. This is a representation. You can directly write like T critical. It is also correct. This value is calculated using the table. That table is called as chi-square distribution table, where row represent the alpha and row represent the DF and column represent the alpha. So from this table the value is 11.07 and this value is calculated using the test. So I will compare this value with the critical value. So this x square is calculated. You can write x square also, or you can write a x square calculated and compare with this T critical. So this value is 1 and this value is 11.07. That means this calculated value is less than 11.07. So here I will accept the null hypothesis. Accept the null hypothesis. So what is the null hypothesis for this statement? It is there is no significant difference between observed frequency, that is these are the observed frequency, and the expected frequencies. Means we can also write die is fair. Die is fair means what? I will throw the die and every time the values are means their places are suppose 6, 5, 4, 3, 1. All these are close to the expected value. This expected value is 10. So all these values are close to the 10. It is not exactly 10, but they are close to the 10. That means die is fair. This is my null hypothesis, or I can write null hypothesis as there is no significant difference between observations and the expected frequency or expected values. So this is all about the chi-square test for goodness of fit. Thank you.